boldly announced, have publicly declared that they have discovered an entirely new planet distinct from any that has already been found. NASA, renowned for its groundbreaking observations, has shown that the newly discovered planet captivates not just because of its size and location, but also because it emits a glow that seems unnatural. Can this be? Revolutionary discoveries indicate that we are approaching the point of unraveling mysteries that could significantly transform our understanding of the universe. Is this exposure a sign of the likelihood of life beyond Earth? As we investigate the astonishing findings of NASA, we might soon reveal the truth behind these exceptional illuminations. In 2007, NASA initiated the Dawn probe with the objective of exploring some of the most captivating bodies in our solar system neighborhood. Fitted with 3 ion thrusters, Dawn set out on an adventure that began with a 14-month investigation of Vesta, the second-largest rock in the asteroid belt. Dawn provided detailed visuals and metrics, unveiling Vesta's intricate terrain and a wealth of geological evidence. After accomplishing its goals at Vesta, Dawn moved on to what many consider the most exciting part of its expedition, an intensive analysis of Ceres, one of the dwarf planets. Thanks to ion propulsion, Dawn succeeded in escaping Vesta's gravitational pull and heading towards Ceres, something traditional fuel systems could not have achieved. These thrusters provided continuous push, allowing Dawn to travel vast distances and achieve a stable orbit around Ceres. Ceres was first discovered in 1801 by Italian astronomer Giuseppe Piazzi. It is the most substantial object within the asteroid belt, situated between Mars and Jupiter. For decades, it was viewed as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres stands as the largest body in the asteroid belt. Experts eagerly awaited high-resolution images of this mysterious world, which revealed radiant patches scattered across its surface, particularly within a prominent crater named Decatur. These luminescent areas immediately sparked enormous interest. Before dawn, our best glimpses of Ceres came from the Hubble Space Telescope, producing only blurry, low-quality images. Dawn's mission sought to deepen our understanding of how the solar system was formed and the role of water in shaping planetary bodies. The gleaming regions on Ceres, also observed on other space rocks, were thought to consist of reflective materials such as salts deposited by evaporated water. This raised the possibility of cryovolcanism eruptions that release not molten lava but water or salty liquid mixtures. What these puzzling illuminations truly are and what secrets they might disclose about Ceres remains an unanswered question. Could they be evidence of ongoing geological activity, or do they point to something even more extraordinary? Ceres differs from other asteroid belt objects because of its size, mass, composition, and the likelihood of harboring water and frost. Unlike the typical stony asteroids, Ceres resembles a comet, hinting at important clues about the infancy of the solar system. After 2 years of travel, Dawn finally approached Ceres in early 2015, marking a defining moment in its mission. As the spacecraft prepared to send the first close-up images, it revealed a world long hidden in obscurity. Initial snapshots depicted a cratered surface, evidence of countless collisions. But it was the gleaming spots among the dark terrain that captivated scientists and space enthusiasts alike. As images became clearer, specialists debated their origins. Were they icebergs reflecting sunlight, mineral deposits, or signs of cryovolcanic activity? To everyone's surprise, closer analysis showed that the brightest region was not one solid mark, but a cluster of smaller luminous spots. The most widely accepted interpretation was that they were salt deposits from briny water that had reached the surface and evaporated, leaving reflective remnants behind. This suggested that Ceres once possessed geological processes capable of transporting water or brine to its surface. Such findings reshaped earlier views, presenting Ceres as a more dynamic and intricate world. The possibility of subterranean water or brine reservoirs beneath the crust raised exciting questions about its potential for harboring extraterrestrial life. Ceres is often described as a frosty world with a porous surface. Unlike most asteroids composed mainly of rock and metal, Ceres contains a mixture of water ice, clays, and carbonates, making it lighter. This indicates that it holds large reserves of water. Its icy crust and volatile substances suggest a structure more similar to a comet than an asteroid. Experts theorize that Ceres has a unique internal structure with a watery outer layer and an ice-rich core making up nearly half its mass. This slushy mantle may consist of salty water and rock surrounding a heavier central core. The presence of vast ice deposits implies that Ceres may have once had liquid water, particularly if radioactive decay warmed its interior. Adding to the mystery, Ceres contains ammonia-bearing clays, suggesting that it may have originated farther out in the solar system before drifting inward. Since ammonia lowers the freezing point of water, it could allow salty fluids to persist on or beneath the surface. These results provide not only insight into Ceres but also into the evolution of icy bodies across the solar system. Cryovolcanism, though rare compared to Earth's fiery volcanoes, is a powerful natural phenomenon. Instead of producing molten rock, cryovolcanoes expel water, ammonia, or methane, which under extreme cold can exist as liquids or vapors, including the environment found on Ceres. Cryovolcanoes on Ceres function by allowing briny water, laced with dissolved minerals, to make its way to the surface. When exposed to the vacuum of outer space, the fluid swiftly sublimates, transforming directly from solid or liquid into gas, leaving behind shimmering salt deposits. These are the bright spots that can be seen across Ceres. The most notable of these is situated in the Achater crater, especially in an area labeled Spot 5. This region has attracted much attention for its high brightness and frequent shifts noted before dawn. These variations are thought to stem from water sublimation, pointing to activity that could still be cryovolcanic, either occurring now or having ceased not long ago. Ceres continues beyond Spot 5 with numerous other bright areas, each with its own features. These extend beyond a single location and are spread around the surface, pointing to the possibility of widespread activity. The existence of these luminous markings highlights the dynamic and ever-changing character of Ceres, countering the belief that it was a dead or dormant world. As dawn continued collecting detailed images, a wide variety of landforms emerged. The crust of Ceres is dotted with impact craters, each narrating a chapter of the dwarf planet's story. Ceres' terrain is speckled with countless craters, each serving as evidence of the dwarf planet's tumultuous history. These indentations offer valuable insights into the forces that have not only shaped Ceres but also many similar bodies across the solar system. Whether caused by asteroid strikes or other cosmic encounters, these scars contribute to the unique personality of Ceres and highlight its role in the grand account of solar system formation. Moreover, the discovery of ammonia-rich clays on Ceres provides yet another intriguing clue about its origin. Ammonia is known to depress the freezing point of water, which may have enabled the persistence of liquid water on or near the surface either recently or possibly even now. This bolsters the idea that Ceres may have originated in the cooler, outer regions of the solar system before migrating inward to its present orbit. This migratory past could account for many of the peculiar features observed on its surface, including ammonia traces and signs of icy volcanic activity. Despite ongoing research into both the surface and internal structure of Ceres, new findings continue to reshape our perceptions. These discoveries raise questions about planetary formation, the potential for life, and the geological mechanisms that power activity in remote corners of the solar system. Once dismissed as a small, cold asteroid, Ceres has emerged as a celestial body that captivates and defies conventional expectations, prompting us to reevaluate the possibilities on far-off worlds. The Dawn spacecraft, through years of dedicated observation, was crucial in revealing these details. The mission, which produced the sharpest images and most precise data ever collected of this dwarf planet, remains essential to our quest to better understand the solar system. Each photograph sent back from Dawn unveiled additional secrets about this changing world, creating a portrait of a dynamic landscape. These revelations mark just the beginning of what is expected to be ongoing inquiry into the mysteries of our solar system's outer regions. In the coming years, the scientific community will undoubtedly explore the extensive data gathered by Dawn, searching for further clues about the potential for life on Ceres and similar bodies orbiting the Sun. As innovation advances and new exploratory missions are launched, even more astounding discoveries are likely. Will we detect new indications of icy volcanism? Will we uncover further evidence of liquid water beneath Ceres' crust? Time alone will provide the answers. However, one fact remains clear: Ceres' saga is far from over. NASA's exploration of Ceres continues to fascinate the global scientific community with numerous breakthroughs. Among the most enticing aspects of this small world is its intricate internal structure, which may provide essential knowledge about how similar planetary objects formed across the solar system. Researchers are particularly focused on investigating Ceres' unusual surface formations, which imply that it might still be undergoing transformation despite its ancient age. A key driver of this evolution is the presence of water in different physical states, which plays a vital role in shaping the landscape. The identification of briny ice and clear evidence of cryovolcanism arouses new possibilities regarding subsurface geological activity on this tiny planet. Scientists are studying how icy materials may move beneath the surface, potentially creating new landforms. Furthermore, understanding the role of salts in this dynamic could provide deeper insights into how planetary moons and other distant bodies change over time. The exploration of Ceres also opens exciting possibilities for understanding the broader processes shaping icy planets and dwarf planets. Unlike rocky bodies, these frozen entities often exhibit drastically different properties. By analyzing how geological activity has altered Ceres' surface, experts can draw comparisons and enhance our understanding of planetary evolution in the outer solar system. Ceres functions as a living case study of these processes, offering priceless lessons in planetary science. As exploration continues, fresh data from Dawn is expected to yield more insights into the formation, internal structure, and geology of Ceres. Each new image and analysis deepens our comprehension not only of Ceres itself, but also of the forces that have shaped the entire solar system. These insights may ultimately reshape our understanding of the solar system's early years and expand our sense of what is possible in the search for life far from Earth.